We're going to be looking at the graphs of quadratics and how they can change based on a translation. So a graph of a quadratic, remember that normally we're in the form of y equals ax squared plus bx plus c. And you can type that right into your calculator just like that, and it'll pop up and show you the graph based on this. However, it's easier to find the minimum or the maximum, which we know is called the vertex, if you have the equation in a different form. Okay, so to start off with, let's look at some basic terms here. These are what we call roots or zeros. You will have at most two. You could have two, you could have one, you could have no roots whatsoever. Roots are where it crosses the x-axis. Then we have our vertex. Our vertex is our minimum or maximum, depending upon whether your graph is upside down or right side up. It just depends. So like I said, you could plug in, if you were to have an equation in that form of y equals ax squared plus bx plus c, you could find that information. However, I'm going to show you a different way to write it in order to get a better idea of where that vertex would move. So another way to write this is y minus k equals a times x minus h squared, where the vertex is at h comma k. So notice that h comma k are opposite of what you see. So to start off with, let's say that I have the graph of y minus 3 equals 2x plus 1 squared. So I'm going to graph this. Now granted, you could move that 3 over in order to type it into your calculator so you could see this, but I'm going to type it with, I will have to move that, I believe, using Desmos. But we'll try it out and see what happens here. We had x plus 1. Desmos will do it how I want it to, which is great. As you guys can see here, this is my graph. Now notice on my graph, I don't have any roots. It doesn't cross the x-axis, which is fine. But based off of this, my vertex was supposed to be at -1, 3. And if I look over here, this is at +1, and this is, or +1, sorry, -1, and this is at a +3. So this does show that our vertex is at that -1, +3. There are times when you could actually just look at, granted, you could look at this and determine where your vertex is just by looking at it. Now, I want to talk about this a value. So on our graph, we had it as a 2. So I just want to show you guys what's going to happen if we change it to a larger number, to a smaller number, to a negative number, and all of that good stuff. So if I have y minus 3, and I'm going to leave the vertex the same, I'm going to make this larger and be a +4. And then I'm going to go with x plus 1 still to the power of 2. So if you notice here, as this number gets larger, that 4, our graph arms come closer together. As you can probably guess, as we get the 2, let's say it goes smaller. Let's go with a fraction just so it's easier to see. I'm still going to use the same vertex. As you guys can see, and probably expected after looking at the blue graph, the arms get wider. So if I have a negative number, let's go with -2 since that was our original, x plus 1 squared, it flips the graph going downwards. And we've talked about this before, but just to reiterate and to make sure that we're going through this and understanding. So the vertex is at h comma k. A value determines up or down and the width of the arms. So the A value also determines whether we have a minimum or a maximum. If we have it going up, we know that we're going to have a minimum. If it's going down, that's our maximum. Again, these are all things that we can find using our graphing calculator. But it's just, this is our translation, and this is how things get moved around, is with the vertex moving with the h comma k and the A determining how our arms are. So this is how we can look at the graphs of quadratics.